Welcome back, Geometry Scholars. Today's lesson is on perpendicular lines as well as equations of parallel and perpendicular lines. The essential question for today's lesson is, how does algebraic knowledge of lines help to solve problems about geometric concepts? And today's objective is that you will be able to perform geometric constructions of perpendicular lines as well as find the equation of a line that is perpendicular to a given line. Get started right away. On your notes, you will see that you have the perpendicular bisector theorem. And it says that if a point is on the perpendicular bisector of a segment, then it is equidistant, or another way to say it is equal distance. When you combine it together, it's equidistant from the endpoints of the segment. So for example, M is the perpendicular perpendicular bisector of AB. So any point on M, whether it's this point or even point P, it's an equal distance from A and B. That means that this line, this side is the same side as that, okay? Or this point, I can name that point D. And from D to B and D to A, it's the same exact distance. Okay, so any line on the perpendicular bisector is an equal distance to the endpoints of the line that it is bisecting. Okay, moving on. Example 1, we're going to use the diagram shown, and it's telling us that BD is the perpendicular bisector of AC. Again, that means that any point on BD is an equal distance, is the same distance from A as it is to C. So suppose that ED is 16 centimeters. So ED is 16, and DA is 20. Find DC. Well, this point right here is the same distance from A as this point is to C. So if from D to A it's 20, then D to C, it's also 20. So DC is 20 centimeters. We didn't even need to do any math. We didn't have to use the Pythagorean theorem. We used nothing except a little bit of logic in what we already knew. Okay? So again, because this is our perpendicular bisector, this line right here, because it's the perpendicular bisector, that means any point on that line is an equal distance from A and the same distance to C. So D to A is the same as D to C, and E to A is the same as E to C, and B to A is the same as B to C. Okay? Any point on that perpendicular bisector. That being said, I want you to try to find BC. Go ahead and pause the video. Find BC. Okay, the directions information tell you that EC is 15 centimeters, which I drew, and BA is 25 centimeters. So we have to find BC. We have to find this missing piece. I drew that question mark right there. Well, B is an equal distance from C as it is from A. So if BA is 25 centimeters, then BC is also 25 centimeters. So BC is 25 centimeters. Again, no math, just a little bit of logic. Example number 2. We're going to construct the perpendicular bisector of AB. So we're basically making what you see right here, minus obviously the marking. Okay, we're going to make the bisector. So we have a line, just like they had AB and they drew M. We are making the perpendicular bisector. So the first thing that you have to do is place the point of the compass on point A. So if you don't have your compass today, you need to get it out, because you will definitely need it. So place it on A, and using a compass setting that is greater than half of the length of AB. So we see AB right here. You don't really need to measure it. You just have to make sure that the setting is greater than half. So you can see right here, does that look greater than half? No, it doesn't look greater than half. So just go as far out as you want to. Just make sure it's greater than half, and then draw your arc. Okay, again, I've told you before about making nice long arcs so you never have to re-arc. Step 2, without adjusting the compass, place the point of the compass at point B. So we're going to switch it around. We're going to move this over to point B. I'm not adjusting the length at all. And then once you do that, let me make sure it's kind of set right. Okay. Once you do that, again, place the arc, and it says that arc needs to intersect the first arc in 2 places. So we're going to intersect here and there. Okay, so intersected it in 2 places. Label the points of intersection C and D. So this point, I'm naming C, and this point, I'm naming D. Okay, this has been really easy so far. All we've done is make 2 arcs. Okay? Now that we've labeled it C and D, we're going to use a straight edge to draw CD, which is the perpendicular bisector of AB. So I'm using my ruler. I am simply and I'll put my endpoints. There is the perpendicular bisector. So CD is the perpendicular bisector of AB. And then remember, that means any point on CD is the same distance from A as it is to B. So if CA is 25, then CB is also 25. If I make another point right here and I call this point J, if JB is 5, then JA is also 5. Any point on the bisector is an equal distance to the endpoints. Let's move on to example 3. Okay. We're going to construct a line that's perpendicular to L that passes through some point P that is not on L. So we're doing basically the same thing we just did, but the bisector has to specifically pass through P. If you notice here, I just had to create the bisector wherever I wanted, and that I created it right in the middle. But this bisector has to pass through point P. Okay? So the first thing that you need to do is you're going to place the compass at P, and you're going to draw an arc that intersects line L at 2 points. Move your compass over. Okay, so I have the compass placed at point P, and I have to draw an arc that intersects line L at 2 points. So make sure you have it spread out a decent, and it doesn't want to spread, there we go, spread out a decent length, and then arc it. Okay, so let's make sure I actually follow the directions. I'm at point P, I drew an arc, and it intersected at the line at L at 2 points. So name the points A and B, just like the directions say to. And if you want to more easily follow along with me, make sure you label them the same that I just did, A and then B. And then it says to place the point of the compass at point A, and using a compass setting that is greater than half the length of AB, draw an arc. So again, move your compass, and as I showed you on the last one, you don't have to measure AB to see how long it is. Just eyeball it and make sure your setting is greater than half. I think you can judge your, there we go. We obviously know that's not half, okay? So I'm going to go greater than half, and I'm just going to make an arc, and I just moved it. Okay, sorry about that, guys. I had to erase the stuff that I had messed up on. So again, I'm at point A. I can see the setting of my compass is over half the size of AB. Okay, you don't have to measure it. Just make sure it's larger than half. And then draw your arc. And make sure you draw a nice long arc. Okay, now that you've done that, without adjusting the compass, place the point of the compass now at point B. And you're going to do the same exact thing. So I'm going to move it over to point B. I'm not making it any wider or more narrow, I should say, neither. And I'm drawing an arc, and again, this arc has to intersect the first arc at 2 places. So find my arc, and there we go. Okay, and label those points C and D. Okay. And then I'm going to use my straight edge to draw CD, which is the perpendicular bisector of AB, and point P should be on CD. Okay, and so I use my straight edge to draw the perpendicular bisector through CD, because I had a point here at C, a point here at D. I drew the bisector, and notice it went right on top of point P as well. Point P should be on the bisector, okay? You have to be super careful. I actually had to redo my graph because when I shifted the compass, I accidentally didn't line it up perfectly, and so my points were a little off. But when you're drawing your points, they should be right under or right over point P, okay? So this is this particular bisecting construction. And as I mentioned to a lot of you in the class today, obviously the EOC and FSA, you're doing these constructions on the computer, not on paper. So we're practicing them on paper, but we will have opportunities to practice them on the computer, and it will definitely be different. Okay, moving on to our notes now. We're on the second page. Slopes of parallel lines are the exact same. Okay, no math needed, they're the exact same. The slopes of perpendicular lines are opposite reciprocals. And we have already mentioned that in a previous lesson. Opposite reciprocals, or you could use the word negative reciprocals if you don't want to use the word opposite. So if the line we had, the slope was 1/2, the opposite reciprocal of that, I shouldn't say equals because it's not, the opposite reciprocal of that is upside down, so 2/1, and then the opposite sign, negative. Negative 2/1 or -2, whatever way you want to write that. To write an equation, you need two things. You need a point, any point on the line, and you also need the slope. Okay? There are two forms that we'll be working with. In a previous lesson, we talked about standard form, and we will go over standard form again before this unit ends. But standard form was AX plus BY equals C. And the two forms that we're working on today are point-slope form and slope-intercept form. Slope-intercept form, I want you to go ahead and fill in on your own. See if you can figure out point-slope form, see if you can remember slope-intercept form before I give it to you. Slope-intercept form is y equals mx plus b. And this is the most common form. It's probably the easiest form, in my opinion, to work with. And we know that m equals slope and b equals the y-intercept. Okay. Back up to point-slope form. Point-slope form isn't my favorite, but it is useful in some situations. And point-slope form is y minus y1 equals m times x minus x1. And y1 and x1, they are a point on the line, okay? That's the point that we are given when solving, okay? So y1 and x1, or x1 and y1, they're a point actually on the line. And m is still slope. That's universal for all of these forms. Okay, so go ahead, and that should be, your notes should be filled out. We have two examples left, examples 4 and 5. Write the equation of each line in slope-intercept form. So looking at our first example, the line is parallel to y equals negative 5x plus 1. This is already written in slope-intercept form, which is nice. We don't have to convert it to slope-intercept form. So we need to write the equation of each line in slope-intercept form. And the first one says it must be parallel. Look back at your notes. What kind of slope is parallel? Parallel is the same slope. So our slope for this line is -5, and it's going to stay -5. Okay? It's going to stay -5. So I'm going to set up my equation. Y equals mx plus b, because I'm using slope-intercept form. The y they gave me is 2 equals the slope, still -5, the x, -1, plus b. Okay, because I have to find the b. I have to find the y-intercept. I have the slope already. I already have that. I have to find this because the y and the x I leave alone. So 2 equals, what's -5 times -1? +5 plus b. Subtract 5 from both sides. -3 equals b. So now I have my y-intercept. So I need to rewrite this, plugging in the information. Slope-intercept form is y equals mx plus b. So y stays the same. M, -5, x, and then plus b. The b is -3. So this is your final answer. This line is parallel to this line because it has the exact same slope. Okay, so we're going to move on to example, we're still on example 4. This is point B, letter B. We need the line that's parallel to y equals 1/3 x plus 4, and that passes through the point 9 minus 6. Again, slope-intercept form is y equals mx plus b. And to have this in slope-intercept form, we have to have the m, we have to have the b. Okay? So the m is basically already given to us because this is a parallel line, so the slopes are what? The slopes are the same. So this slope is 1/3. So I already know my slope is going to be 1/3 because we're working with a parallel line. They also give me the x and the y. So I can plug that in and find b. So -6 equals m 1/3 times x, which is 9, plus b. -6 equals 1/3 times 9 is 9/3, which is 3. Okay, plus b. Subtract 3 from both sides. -9 equals b. So now I take everything I've been given and I plug it in. I leave it as y equals m 1/3 x, leave x alone, minus 9. And here is my line that's parallel to my original one. Again, I know it's parallel because it has the same slope. They both have a slope of 1/3. And it's written in slope-intercept form, y equals mx plus b. Okay? And again, I use the slope. I use this point, and I plug them in here and here and here. That gave me the b, and then I was able to plug the b in where it belongs. Okay, one more example, example 5. The same exact thing, except this time we're finding a line that is perpendicular to the line they give us. And remember, perpendicular is the opposite reciprocal. So this first one is y equals 4x minus 2. So what's the slope? What is the slope that they give us? The slope is 4. But remember, we're not doing parallel lines this time, we're doing perpendicular. Perpendicular slopes are the opposite reciprocal. So the opposite sign, so now it's going to be negative, and the reciprocal, turning it upside down, 1/4. So the slope we're working with is actually -1/4. So I'm going to write that right here. And erase old stuff so we don't get messed up. -1/4 is the slope of our line. Okay? So y equals mx plus b, first step. And plug in everything you know. Go ahead and pause the video, and I want you to plug in everything that you know. Okay? I plugged in -1 for y because they gave us that. I plugged in -1/4 for m because we found that. I plugged in 3 for x because they gave us that. And then plus b. So -1 equals -3/4 plus b. I need to add 3/4 to both sides. So -1 plus 3/4. -1 is the same thing as -4/4. Okay, 4/4 is 1. So I'm going to add 3/4 to it. -4 plus 3 is -1. So -1 plus 3/4 is -1/4. So -1/4 equals b. So now I have my m and my b. I can come back and plug all of this in. Y equals -1/4 x minus 1, should it be -1/4? -1/4. There we go. And our last example is the same exact thing, finding the line that's perpendicular to y equals -2/5 x plus 12. First thing I want you to do is please tell me what the slope would be. If it's currently -2/5 and we need the opposite reciprocal, what is the slope? Okay. It would be a positive 5/2. Okay, positive 5/2. The opposite, the change the sign, reciprocal, upside down. Perpendicular bisector in slope-intercept form, y equals mx plus b. Go ahead and plug in what we already know. We know the -6, we know the -8, and we know the 5/2. Okay. You should have -8 equals 5/2, or 5/2, times -6 plus b. Go ahead and please solve for b. Go all the way down until you have one answer for b. Okay, so I had everything plugged in. 5 times -6 is -30/2. -30/2 reduces to -15. I added 15 to both sides. -8 plus 15 is 7. So the b equals 7. Go ahead and plug in the b and the slope for your final answer. And your final answer is y equals 5 halves x plus 7. And this line is perpendicular to our original line. Again, I know it's perpendicular because the slopes are opposite reciprocals, upside down and the opposite sign. Okay. Lastly, you need to go ahead and write a summary of what you've learned today. Either one sentence of what you've learned or something you're having a difficult time on, or if you have any questions, make sure they're in the margins for me as well. Thank you guys very much. See you next class.